cuando llegue a 0 ya puedo empezar a hablar. Sí, lo veo desde aquí, yo el contador.
I don't know how much time you have for how much questions. I have time, so be free.
Yeah. Hola, buenos días. Continuamos con la serie de charlas de la Escuela Técnica Superior de Ingeniería de Informática. En esta ocasión tenemos el placer de contar con Michael Abbey. Él es ingeniero de software de la empresa Wolf y nos va a presentar un marco de implementación de inteligencia artificial para la empresa alemana BMW. Gracias por venir a asistir aquí en presencial y sobre todo gracias a Wolf. Yeah. Thanks, Michael, for your time here and sharing with us your experience in this really nice project.
Thank you very much. I didn't understand one word because I only can speak English. I hope it's not a problem for you guys, but I'm thankful to be here. I'm coming freshly from the KubeCon, which is close by here in Valencia. 40 of my colleagues are there. And I'm standing here today with you, giving you this talk. So, hello, my name is Michael Abbey. I give you a talk about how to build a cloud platform for AI. And it's about 45 minutes. We have time for questions, so cozy round. So everybody doesn't understand something, just raise your hand or just grab into, no problem at all. Afterwards, we have an open session for questions and answers. Hopefully, the stream, one of my colleagues from BMW, which gave us the opportunity and the approval, they will say, okay, we can tell a little bit about the project behind this talk, is also in the call. So first of all, some pretty simple things. Who am I? My name is Michael Abbey already. I'm a software engineer. I understand myself. I'm in IT for already 15 years now. And the last 9 years with a company called Wolf. It's an IT company, IT consulting company in Munich. I'm not sure if you know it already. Somebody maybe, the 4OE maybe already experienced them? Okay, not so far, totally fine. Software engineer, right. I started as a small programmer in a product house in a small city called Augsburg at the time, 3 years. We learned hardcore programming at that time. And then the world was not big enough anymore. And I moved to Munich and wanted to be an IT architect. Okay, it was next stage. Then you coming normally in touch with the customer, of course. Then you come into responsibilities, project lead. The next one was, okay, this is not so, was from 1 year ago. We have now a department of about 60 people I'm in. It's called DevOps and Cloud Natives. It was founded 4 years ago. And there I am now the deputy head. And beside that, I call myself a cloud evangelist because I love the idea of the cloud, not because I want to get money from the big cloud vendors, AWS or something like this. I find the idea behind it very, very intriguing. And a DevOps mindset. About 5 years ago, I was by coincidence landed in an operations department, really at a customer place, and they said, we have a big need for automation. And I, as a programmer, was there, so what do you want from me? But I learned in these 2 years what it means to be, what DevOps really means, how this new way of working together, this mindset thing about DevOps. This is something which really convinced me, and this is one of the things which I convinced now customers in Germany, mostly in Germany. About private self, I like to travel, read manga, and a lot of nonfiction. Also, missing is food. About 1 hour ago, I was at the Mercato Central and bought a big bag of olives and chamon for my parents at home. So this is also one of my things I love. If you want to follow me, you can go on Twitter, Shadow Molder it's called, or on LinkedIn. You can always get me. And of course, Cesar can also host. A little bit maybe about the company I'm working with. As you don't know so much about it, was founded about 30 years ago in 1998 in Munich. At that time, of course, it's very small and cozy company with maybe 10 people, and we are nowadays nearly 700 people over 8 offices spread over Europe and plus Tunis. We are having 12 departments inside, and the departments are mostly divided by a topic. It's not so that we say, okay, for example, I'm coming out of DevOps and Cloud Native department, the others coming from HR department, blockchain, and so on and so on. Also mobile, front end. But it doesn't mean that they're only doing this thing. This is more like we all understand each other as a software engineer, and this is the flavor we are adding to it. And we say, okay, this kind of area I want to specialize. That's the reason why. We're also not focused on customers. It's more like we doing as a company together the customers. So if there's somebody, for example, like BMW, say, hey, I have a project for you, then we're looking, okay, what are the best people for fulfilling this? 2010, Great Place to Work. I'm not sure if it's so known here in Spain. Do you know the Great Place to Work? It's an organization which in Germany, which where you can apply and can ask yourself how satisfied the people who are working for you are with the company. And they're doing anonymously assessment. And in the end of the year, they are announcing the Great Place to Work, also the best companies in Germany to work for. And we win this prize, I think, since 2010. Not always first place, but always, at least in the first three on the stage. Yes. Okay, of course. Where can you find us? As already said, we have in Germany, at least, we have the biggest offices. I think it's Munich, Hamburg, Frankfurt. Then we have Berlin, Augsburg, Darmstadt. I think most of the names you don't know where it is, but let's say Munich was the founding city. And since 4 years, we have in Tunis. We're also growing very fast there. Also out of the idea, say, okay, not because it's cheaper to get there, it's more like, okay, hey, there are also very good educated people there on site and motivated. And they're working together with our projects. And our newest office is here in Valencia. It's about founded from 1 year ago. And to make it clear, we are not here to say, okay, yes, it's nice weather and it's cheaper, maybe. It's really, we want to invest into Valencia. Also, we want to, this is one of the reasons why I'm giving this talk here, because you are the next generation. So, and this is not solely happening in Germany, the magic is happening all over the world. You know, we will one day, since Corona hit us, we will say remote is more and more the normal way we work together, or let's say in a hybrid way. So we can work from different branches and can work together on one project. This is something I'm really looking forward. So Valencia is our next one, and probably is not our last one. And the way of offices are founded in my world is always the same. Somebody said, I want to do this. It's not so that somebody or C-level says, yes, we need to found an office here. It's more like somebody says, hey, I don't want to work in Germany anymore. I want to go to Valencia back because I'm from here. I want to open my office. And it's the same way we do everything else. Yes. So what we talk about, in a very rough agenda, we will decompose these 3 terms of cloud, platform, and AI first, and then we put it back together. So there's always pros and cons and what different challenges with this, and how you can bring this together. And in the end, I will show you a project from BMW. It's called Natural Language Processing project BMW NLP project from BMW. I worked for them for 1 year, let's say, to clean up their platform, because it was a little bit a mixture of a lot of different things, and they had a need to bring it all together. And there I experienced the first time what is important if you build platform for artificial intelligence services. Guys, in the end, we sum it up, and if you have questions, as you always say, just ask them. So, this was one too much. So, I starting normally very, very high. Normally we talk about tech. I mean, you study tech and everything, and you want to get good in it. But if you first approach a customer, he doesn't talk about tech. He doesn't want to talk about his business. He wants to have something for his money. How it is solved is not important. This is our problem. Let's say that this is our job. So if you see it from bottom up, you have there the technology. This is the main work of us. Then we have system architecture, which is, let's say, high level. How to structure these things. And on top, I call it why. I will go on to this thing. Does somebody know of you, Simon Sinek? I think it's a well-known name from YouTube normally. You find very good talks from him there. So this principle of why, how, and what. If not, it's a good homework for you. Believe me, it makes totally sense. And today we're talking about the why. I will tell you more about this overall talk and a little bit about system architecture and not about tech, because we have only 45 minutes. And if I were to go into tech, I need to grab something else, something very small, and then we talk about this. But this is a huge world, what we are out there. So first, let's talk about cloud. I think everybody knows about a little bit about this, the big three vendors, AWS, Azure, Google, and much more outside there. This is Wild Wild West, and yeah, we don't talk about the weather now. Cloud. About 4 years ago, we asked ourselves how many cloud services are out there, because when you look into it, in Amazon, there's a lot of thousand services, and I asked myself, okay, how much of them do I need now as a software engineer? And now it's a question to you. I'm also asking some of you questions. Guess how many services are out there for the 3 big cloud vendors? Make a guess number.
300.
300. Okay, 300. More or less?
What do you mean by services?
For example, EC2, S3, Lambdas, whatever you call it, every dedicated service you can use and configure there. Virtual machines, for example, is a service from AWS. I'm specialized in AWS because I'm also regulated.
Maybe 1,000.
How much?
1,000.
1,000. Okay, that's a high one. But yes, I take it into account. Maybe another one. Okay, keep it with the thousands. I counted it 1 week before. It's about over 500 now. And it was 4 years ago. It was about 400. So the number is growing every year by, let's say, 20 to 30 new services coming around the corner. Alone, AWS has over 2,200 services, which is insane, because you cannot have all of them. You cannot know all of them, because all of them are specific to a certain kind of IT part. If it's blockchain, if it's front end, if it's infrastructure, whatever you name it, you get it there. There's even for satellites, it's a service there. You can rent a ground station for satellites. If you have satellite there, you can say, hey, I have a ground station, I need to use it. I had a customer, and it's not something which is nice and fancy. It's really this kind of service I used. We had a project with a car manufacturer who tested his cars in the desert, and the problem is this car produced so much data, and there was of course no internet there. So what they did, they brought a big car with them with a satellite on top of it, a satellite station, and put the data there from there and send it directly into the cloud. So this is a use case, and it's used, and there's much more outside. So if you're hitting the cloud, you need to think about, so shit, what do I really need from that? So again, here starts when I talked about specialization, because with what cloud vendor I'm starting. Okay, what is normally what I want to use things? I want to just have a website. What do I need for a website? 3, 4 services, 20? I don't know. Just upfront, I think it's good to know 5 services very well. So for example, AWS, it's mostly S3, VPC, EC2. Okay, this is, let's say, pretty simple. It's network, it's computing power, what you need, storage, and some 2, 3 other 4. Which maybe needs Lambda is also would put in the list now, so serverless functions, if they already know it. And then plus 20, which you rarely use just for certain kinds of use cases. I have a ETL pipeline for data science, then I grab the right service out of it, and a half year later I don't use it anymore. But at least I used it. But the cool thing is in the cloud is everything there is uniformed. When you know it for one service how to use it, it's normally very easy to use the next services and so on. Of course, you need specific knowledge about how to build it, especially for security reasons, network, for example. You just don't come there and say, okay, I'm a developer, I put here a network, and it will work. That's not the way it does. You need somebody specialized in operations and networking. But more to this later. So this website is online. It's called on a cloud landscape.info. You get data slides from it. You can have a look. I think it's last 2 years it wasn't updated, but at least you get an impression how many servers are out there. And now gets one thing. So CNCF. Does nobody know the abbreviation? I can say the first letter we already had. It's cloud. Maybe the second one.
Network.
No, it wasn't. Native, that's right. And the rest the last two letters?
Science. Science.
Nee, science. A computer
Foundation, format.
Thank you. It was the foundation. Cloud Native Community Foundation. So we talked about cloud before. So now you need to ask yourself, the cloud vendors, they have tech behind all of this. So they have the best software engineers in the world, and they're building services for others, infrastructure, storages, networking, and whatever so on. But the question is, this all stuff is, for example, hosted in America. So if I have, for example, compliances, which is a governance compliance, where I say, I cannot do this, I need to do it on site. And this data needs to stay with me. I cannot send it to US. It's not legal, for example, banks and so on. So what I do then? And for this, we have open source. And the Cloud Native Foundation put together a landscape, exactly the one as before, just for open source toolings where you can build your own cloud. And I think all of you ever heard of Kubernetes, right? If not, this is just cluster for containers where we can auto scale. So if I, for example, say I have a Docker container and there's my website inside hosted, and the more traffic comes, the more I want to scale out. And of course, I don't want to pay thousands of dollars upfront. I want to just pay what I currently need. And Kubernetes can help underneath to fulfill this requirement. And there's a lot of other tools on this. Guess how many on this landscape? This time I can tell you it's more than the cloud vendors have. You like high numbers, right? But let's stay with the thousands you had already, because it's close there. It's over 1,000 open source projects out there which are known on the cloud native landscape. So it's a jungle. It is unbelievable how much services, more than the cloud vendors have. And again, here I need to ask myself, what do I need from that? This is a job for its own, just to scan this, and just upfront, you don't need to know them all. That's the good thing you have a landscape, is they can show you what is maybe important and what's not. What they do, for example, they show the by maturity. I say, okay, which open source project has the most maintainers, the most backing from other companies, and so on and so on and so forth. The biggest community behind this. So what you definitely need to remember is Kubernetes, Grafana, Helm. I don't go in detail because I don't go deep into tech, because all of them I can do a talk about, or a workshop for 1-2 days just to understand this.
They had a workshop last week about Kubernetes. They had a workshop by your company.
Yes, right. We had a workshop last week about orchestration and containerization. This is only one part of this. This is one tiny bit there you find. In parallel, funny as is, there's the KubeCon right now. Does anyone know this conference? If not, it's just in the name. It's a conference which is, I think, every year, a different place in Europe or also in the world, which has a focus on cloud native, so this landscape, plus Kubernetes. And currently there are 7,000 people there on site and 10,000 people online. So this is a big thing. Every big company thinks about this, has people, operations people there inside who uses these tools there on the landscape. So it's a serious topic. So yes, so I think we can remember this is a mass game what we are doing here. And so Now let's talk about platform. Before we talked about cloud, and maybe for the most of you, cloud and platform was the same, but it's already learned, okay, hey, we don't need to always a cloud vendor, we also can do it by ourselves. Now we talk about platform. And when I talk about platform, it's not only cloud platform, because in the old times, before 10 years ago, before AWS started to hit the market, there wasn't a vendor, or not, let's say there was some, but they didn't have the quality and the mass of services to exclude their IT to somebody else. So platform, there's a little bit of look on the time. Okay, I don't know where to start it. Sorry. It's a manual process. We normally would automate this. So what you see here is, I would call it building blocks. And let's start with from the bottom up. Normally, I ask the customer, we're starting a new project, greenfield. Here there's an idea, they brought money, we brought a team. Then the first thing you ask is the question why. Why are we doing things? So it's already clarified. I would call this a vision. So the vision is, I think. I know the use case. It can be IoT, ETL pipelines, workloads, online services like websites, or whatever you call it. So there's a lot of use case there outside. And for every of those, you can build a platform differently. But the good news is platforms you're building already since a long, long time. Since a computer exists, we're also building platforms and networks and infrastructure. So there's a lot of experience already there. One of the first things I normally start, so what was also important is maybe this is called non-functional requirement, also sometimes call them ilities, because there's a set of terms, or 20 to 30, which you should ask your customer for example, what are you focusing on? So you need your platform be reliable, scalable, available. It needs to be very special, resilient, security sometimes for banks, for example, is very important. Then after this questions are verified, you ask yourself, what is the abstraction level? And this is the one thing I didn't talk before, but when we talked about cloud. The cloud vendor, for example, makes it very easy for you. They say, okay, have here a bare metal virtual machine, or here just the OS, and you can build on top of it. Or what I say, I'm not very strong with Linux, I just want to host a website. Then there is maybe a service which is already give it you an automated way, and say I have here only upload my zip file, and there's my website inside hosted, and the rest is done by the cloud vendor. And the last version is a totally lazy one. It's called SaaS. There you get already everything finished out of the box. You're just clicking it through together, configure a little bit, and say, okay, this exact way I want to have it. So this question you need to raise. And the last one is, this goes more in the technical way. So then we talk about architecture. You need to ask, okay, what are the best way of planning and designing this kind of platform I want? And if we talk about platform, it's about three things. The first thing is I have a common ground, such, let's say, guidelines. I ask myself, okay, what we want to achieve? Can we agree on certain kinds of terms and goals? So this is mostly documentation. Documentation mostly. Then comes this platform word, and platforms unfortunately very overloaded the word. You can also say infrastructure to it. So just bare metal, virtual machines, network, whatever you want. And on top of it, we have our applications running on top of this. So I'm not sure what things you are working here. Probably maybe a Tomcat or JBoss or whatever it is. Let's say those are the platform for you. So you have something, and on top of it, I have a small zip file or an archive or release, whatever you want to call it. And on top of you deploy it. And this depends on the use case, of course. You choose your platform, how it should look like. I make it a little bit easier. Let's say from the left to the right, I am a total noob with networking. I don't want to know anything about it, or it's not my specialization. I'm just good in front end, let's say like this. And I don't have a team of operations who are handling for me this whole things. Then I maybe choose a cloud provider and say, okay, do this for me. And I just have here my JavaScript and HTML, deploy it there, and I'm done. I just pay then by what I really need. Then, of course, bigger customers come around the corner and say, okay, I have different use cases, and I don't want to give away all my expertise, which I have, or have special requirements. I need to host it on site. Then you probably go with something with like Kubernetes. And then you host it on your virtual machine, for example. Maybe there's a server and then in the cellar there, and you can use it. And the last one is it's just virtual machines or bare metal. Jump over this because of time. So here it gets tricky because I am not a data scientist. I'm a software engineer who specialized on DevOps and cloud native, but AI is for me dark magic. I have no idea how this works inside, and probably as a lot of other people too. But luckily, the possibility to work 1 year together with BMW and with data scientists, and I stood a little bit from it. So this little bit. I put it together in this small diagram here. As I far understood, from the terming, when we talk about artificial intelligence, we try to, this is the idea of mimicking the human behavior. Just to automate ourselves, let's say like this. Then a subset of it is machine learning, and this is using statistical methods to improve it and repeat it as long as to meet a human experience. For example, hey, I want to all see all pictures with a dog inside it, and then the computer brings out these pictures and say, okay, I say this is the wrong one. I say to the computer, no, this is not a dog, this is a cat. Then he learns from it. So this is also machine learning. There's a whole huge world behind this. It's just super simplification what I'm doing right now. So please don't help me if I'm totally wrong with it. And the last one is deep learning. You also probably heard this, and this uses artificial neural networks. And this is also a subset of machine learning, and it's adapt and learn from so much data you cannot control it afterwards. It's not so this dog and cat example. The human will not get there and say, okay, this is a cat, this is a cat, because there are 1 million cats. Maybe the computer bring board out in the first moment. So you need different methods to get there. And one last of it, and this is what the project we'll talk about. It's natural language processing. It's a mixture of machine learning and deep learning, and this is about really specialization about, for example, text generation, text speech recognition. It's really about what we hear and say, and the computer needs to understand this. How is it possible? So, and now it gets a little complicated. These are the things I learned a little bit. Are data science years today? Well, at least you have a little experience with it.
Yeah, okay. Well, these first two rows, they are doing data science degree. So,
but who?
There's the first two rows. Yeah,
so
6 people.
Okay, the rest of us. Then I'm simplified a little bit. From a very far away, data scientists are trying to mimic human behavior by using statistical methods, and then they have their tools for it. There are thousands of tools. Again, you can put up a new landscape just from the tooling which they have, and they just try to create some kind of an artifact where I say, okay, I have an input and an output. So let's stay with I searching for the dog pictures. So I give here 1 million dog pictures inside, or let's say 1 million pictures, and I get out 3 dog pictures, and the rest is thrown away. So this is the expectation on this, and let's say this in and out we leave out for now, and there's this black box, which is doing all the magic. And this magic is trained by machines, not by humans, because before we coded logic into the computer. Now the machine does do by himself. So this is they call it as a model, and in this model you find this logic inside. And now it gets a little bit more trickier. The problem is it's not when I said about training, it's not so that is not happen. So let's say I have used a tool for this and I configured it and I tried it out. So the first time it doesn't work very well. Maybe they're coming out 20,000 dog pictures. So it's too much, of course. I reconfigure again 10,000, 5,000, 6,000, and whatsoever. So it's going about a quality which comes out afterwards, and this takes time. And a lot of versions of this. So sometimes it's, let's say we have simplified this before. I said dog pictures, but let's say I want to have dog pictures, cat pictures, humans. So it's now getting more complicated. And the more complicated it gets, the more models you are training. And you ask yourself, okay, which model, which version was the best? And this makes, for example, the life of platform creators very hard, because we are normally used, we have one artifact, let's say one model, I deploy it and then it runs. But this case, it isn't like this. You have multiple artifacts and they're changing the whole time, because I want to improve it step by step. And this is a really big difference to other software engineering parts, that you have multiple versions, multiple tools, and they're all trying to refine this model the whole time till I get a quality I want. Other things which are part of this, I think if I put it down to 3 non-functional requirements, it's mostly about performance. So it shouldn't take too long to train a model. It can take days if you have not the right computer for this. It's about throughput, because you have millions of data. Also, your network, this is really a thing. You have mass of data, and the question of quality. I already said, I want to have exactly the 3 dog pictures I want, and not the 1 million after, other 1 millions. Also, huge world. You can build up platforms just to build machine learning platforms on top of it. Then we're talking about tools like Hadoop and Spark, or you just go to the cloud vendor and say, do you have a service maybe which does it already? But of course, small money or bigger ones. Yes. From time jumping over a little bit over the other ones, there's a lot of naming there outside. For example, called the word data scientist, big data, business analyst. So, but don't overthink this too much. It's more or less, as I said, it's a kind of specialization. In the end, we are all software engineers, and there you're choosing your flavor, what you want to come to be. So I think if you're good data scientist, you are a very good software engineer. Plus, you're very good in math. So these two features I think you need. Right. So let's put this all together. Cloud platform AI. Its secret sauce is always teamwork. You can always say this doesn't work. What we learned is, on top of it, we have the cloud, and there we have a mass of data there inside. It's services, and you need to choose your devil wisely. So not the 200 AWS search. I need to search for really those 20 I really need. And then again, I need to ask myself, are these the right services? Or I maybe need to use the cloud native landscape and build it on top of my own, because I need flexibility, which the cloud provider maybe doesn't provide, because this is a unified service. This is just the way it is, and they don't customize for you. It's just you need to take it as is. Exactly. So the second thing is platform. Let's say I start with AI. As I always said, we're all software engineers. So the problems which are facing there inside is very similar to the other ones, building, let's say, a website or ETL or whatever it's call it. But it's also a little bit different, because you have these models there which you need to retrain. You have a lot of data and so on and so on. And the last one is platform. And the good thing is we've been building platforms for a very long time. And since, especially for the last 10 years, there is this idea of DevOps came up. And as I always said, this is a mindset. It's not a tool. It's the way we work together. And together, I mean, we all work on the same goal or vision. It's the reason why I'm always putting the word why in front of everything. Why we are doing this. Because if you don't ask this, you maybe misunderstand it, and then you're doing something totally wrong. And the customer doesn't pay you for this. I don't know. And of course, if you put all these 3 together in one team in a good mixture, you will reach what the customer asks for you. So now we come to the part I think you're all looking forward. BMW Car Sportive, wonderful. My work works with BMW already for a very long time, with different kinds of projects. So this project was the first time an AI project, or a language project in this case. And they started with an interesting setup. They said, okay, we have here 4 different natural language processing projects, and we need to put it together under one team. It doesn't say under one platform, but at least under one team. So there was 50 people who were working on 4 different projects. So can you tell a little bit about it? The first one, for example, is called custom translation, and you can imagine it's like an internal Google Translate. And why BMW should create its own Google Translate? It's a little bit simple. I said it before. You never know where the data you adding into Google Translate ends up in US. It's not so that the US are bad. It's just you have certain kinds of compliances to fulfill. And one is maybe, okay, I cannot put every text there inside. And plus the fact BMW has a lot of specific terms. I mean, they're building a complex car there inside, and they're using their own language for this. And Google Translate doesn't know about this language. So they created something, a custom translation. And there are servers out there in the cloud native landscape too, and also from the cloud vendors. Second one was, that was pretty impressive to be honest, was really was interesting. Social media analysis. Sounds scary, but it isn't. It's about when I'm scanning a text, I can find out the sentiment. So for example, somebody wrote, I like this new wheel of BMW M4. Then I can give stars for it. Say, hey, okay, this person is really satisfied. But if somebody else wrote, say, yeah, it's okay, but I'm not sure, maybe last car was better. So I give 3 stars out of 5. So this is called, this is some kind of rating for sentiment. And you can read out of the text. This is unbelievable. The other tools are more pragmatic. The other one is forecast. You need to see it like this. They're producing a lot of documents, a lot. And the problem is how you bring it together. So also this thousands of people are working for BMW bring the best together. So there's a lot of information I don't need, some I need, and they have internal database for this, how we bring this together. And this bringing together again is something you need text recognition or some kind of intelligence, because just to scan a text is not only, because language is not like a computer or 0 or 1. It's not, you can interpret it in different ways. As I already said with sentiment, sometimes a wheel doesn't mean it's positive or negative. It depends which other words you're using for it. And the same is with other documents. So this forecasting is a little bit about bringing together in an intelligent way. And requirements engineers is exactly the same thing. There's a lot of requirements, documents they're creating. So they also scanned and compared later. For example, there's, let's say in one branch, we said there are 20 cars who had a problem, but this 20 cars was not on one repair station. It was over 20 over Germany or Europe. And now we bring it together on one place. And this kind of work is also, you need some intelligence behind this. Again, we have the team here. In this case, this was a team mixture out of software engineers and data scientists, platform engineers, Scrum Master, project lead, IT architects, mixed out of Tunis and Germany. So it's really half Tunis people, the other half was from Germany. And in the middle, of course, there's always a customer, and they normally bring 2 people. It's the product owner who has the vision, the business in mind, and the IT architect who gives, let's say, okay, this direction we want to go from a tech side. So they talk a lot to each other, and they depends to who they talk again. And of course, a lot of other people. The secret is listen very, very good to your customer, what they want, and always ask the question why. And till they can repeat definitely what they want, and they say, yes, this is also what I meant. So, and this you need to do very, very often, continuously, the whole time. So this is our secret sauce you can put on every dish, believe me. Yes. I hope in the future we will have also well-engineered colleagues here. But let's see. Right. Some challenges we faced, especially in this project context, was I already told you this was 4 different projects that put together, and yes, of course, every project has its own flavor and maybe get technical depths, brownfield, and there was used different kind of technologies also. So there was no common ground there. So the first task was to, okay, let's find a way with what they all share. And the first things are, okay, hey, the kind of way we're building for platforms as a way, for example, naming conventions. It sounds boring, but it's very simple. If you have it once, and say, okay, every new line of code needs to follow the naming convention. Quality of code there inside, you need to improve by the Boy Scout rules. So every time you touch code, you need to improve it. Also, for example, this thing with the with the naming conventions, or clean code, you maybe heard of it. If not, please read the book. It's the Bible of every software engineer. You will one day refactor a lot of code in your as a programmer. So this is important. Yes, and of course, there's also a lot of things. I mean, we got this from BMW, this work project, and it was the first phase. Was okay, Jesus Christ, there was so many code, so many platform. We need to dig through it. So it also took a lot of time to get there. Yes. Yeah, there was also a lot of constant change. I mean, we got this for projects, but not to say, okay, here we maintain it and keep it like it is. It's more like, hey, there was the product owner brought new requirements and we need to edit it again. So while we are improving the platform and the software, we need to add new features like operating on a living heart. This is not that easy and needs a lot of focus and remember yourself why I'm doing stuff like this. There was a lot of tech depths inside. We sanitized. We did a lot of automation and prepare. Some kind of the software didn't work anymore, and we don't know how it works inside. So we dig into it, repair it, bring it into the new world where everything is better. And something very special, I call it lost in architecture. Yes, from the movie Lost in Language. Here I show you something. Whoever saw an architecture diagram before? I mean, probably you saw once. The problem is, I'm somebody who started studying in the beginning of the century, and there we was building monoliths, a really big, huge kind of software in one repository, and our job was to keep it clean inside. But since we have this cloud provider and the trend to distributed system and get every feature much more smaller, so before we had one big monolith there, black box, now we cut it into very, very small pieces, and it ends up like this. The problem is, when I ask somebody, find the feature logging or the feature, hey, red button on the surface, you wouldn't find it there. You would have a really hard time. And even if you find it, you don't know if it's maybe related, if this is maybe related to this one and this one and this one. You have no idea. This is the drawback of getting every time smaller and smaller and distributed. Yes, we have can be scalable, very easy to use, but unfortunately, it's a mess if you don't have an eye on this. So, sorry. Okay. This is the way I orientate. So it's also things. So if on the right side as a user here, for example, and he's pushing any button there. And now what is happening? And it's also getting complicated inside, because not every way is the same. So 3 different use cases, 3 different lines, and one use case has different configuration. Boom, another lines getting up. It's like a subway map in the end. And also this is getting complicated. So on top of it, what effect does it have? What use case workflow I'm going through? The architecture. How to solve this? Yeah, it's a lot of work to go through it and put it into domains. There's really logical domains. So this is the one moment where you need to put up your technical glasses and need to ask yourself about business again. So you build a system not for yourself or because you want to fulfill your technical dreams. It's about because somebody had a business problem, a real problem in the world. So, and from this glasses out of it, you need to cut your architecture, your software, the namings, everything is going in the direction of business. It's never about technology. Technology is only the how I'm doing it, but never the reason, not the why. This is something very, very important. So for this, let's say you are trying to take this huge picture and ask yourself, okay, which parts belong to UI, which parts belong to feature X, and so on and so forth. And if there are things which are shared in each other, then you need to separate it again till the picture is clear for everybody. This kind of picture needs to be explained in 5 minutes to somebody else, either the product owner, the business analyst, or a technician. This is a common picture which is explaining what we're trying to do. because this fulfills the business needs. So when you are in a situation, you have an architecture which is much too big, take the time up front and ask yourself, okay, which kind of domains I can cut this? Because yes, we cut our monoliths from back there into smaller pieces, but to be honest, the network itself now is a monolith. Because if you can't cut it, you cannot move it out. For example, let's say I want to put the UI to another cloud vendor. The picture before, we couldn't do this. It was too entangled, too much. So in this kind of way, we have the possibility. So I think, yeah, I need to come to an end. Production readiness. It's a term out of operations. This is the moment where you normally say, okay, I'm getting productive. I give it to the outside world. And the word readiness it's kind of a joke because you are never ready. In the moment when you put an API online, everybody can reach it. In this moment, you are productive. So, but there's so much to do for security reasons, for automation, for example, when something happening, how fast I can fix it, and so on and so forth. This is an own world for itself, which I talked about before, cloud native, cloud, and there are specialized people on this. This has nothing to do with data science. It's about people who just focusing on this. We call it normally ops, and in this case, but also already involved into this. You also have the quote, you build it, you run it. So it's good to know a little bit about this stuff. But this is a talk for its own. Every of those we have a talk about 2 days workshop. Yeah, if you're interested. So I think I'm through this. Not completely. Sum it up. So if you go out of this talk and remember 3 things, I'm very, very happy. And these 3 things are: start always with the word why. I know this sounds like a little, when you read now the title of this talk and I say, why? No, you can always start with the word why. It's because make sure that you're doing the right thing, and then you can do it right afterwards. It's much more important. We are all technicians. We love it. We all have this curiosity in ourselves to dig into technology. But the truth is, we're not getting paid for this. This is just how we're doing it, our tools. But the why, the reason, is always for the business, the one who is having the vision and the idea. And there we should orientate ourselves. Doesn't mean that you can go home and do whatever you like, but for business reasons, you make a favor of yourself and listen to them. Pick your tech wisely. You already saw this Wild West is a huge world of thousands of tools, and you ask yourself, where should I begin? And better take a little bit consideration about this. So ask yourself what I want to do, what I'm interested in, what the world maybe needs. And out of this, I'm choosing my tech. Of course, you can also, for the curiosity, learn text, which is also cool, also a good idea. But there will be tech which is not in your side. We say, okay, this is something normally a known touch, but it's a good idea to know it. And yeah, become an awesome software engineer, because we're all software engineers. The rest is only specialization. And this is my last words on this. If you have questions, please raise it.